Title: How a Solar Storm Changed Communication Forever. It begins with a flicker. Your GPS glitches. The internet goes dead. Not for just you, but for everyone. Within hours, the power grid collapses, plunging the world into a darkness our modern civilization has never truly faced. This isn't science fiction. This is what happens when a silent giant 93 million miles away wakes up. And back in 1859, it gave us a terrifying preview of how it could change our world forever. The year is 1859. The world was just starting to get connected by a game-changing technology, the electric telegraph. For the first time, messages could cross continents and oceans in minutes, not weeks. It was the dawn of global communication, a fragile network of wires humming with the promise of a connected future. On the morning of September 1st, an English amateur astronomer, Richard Carrington, was in his private observatory, sketching a massive cluster of sunspots. Suddenly, he witnessed two patches of intensely bright and white light erupt from the sunspots. It was a brilliant, silent explosion that lasted only 5 minutes. Carrington, having just documented the first-ever observation of a solar flare, had no idea he'd just seen the opening act of a planetary drama. The effects arrived just over 17 hours later, an astonishingly fast journey for a solar eruption. It started with the sky. That night, breathtaking auroras, the northern lights, were seen all around the world, even in places that almost never see them. People in Cuba, Mexico, and Hawaii watched the sky dance with color. The glow over the Rocky Mountains was so bright that gold miners reportedly woke up and started making breakfast, thinking it was morning. In the northeastern United States, people could read newspapers outside by the aurora's light alone. But while the skies put on a beautiful show, the world's new communication network was screaming in agony. Telegraph systems across Europe and North America failed. Telegraph pylons threw sparks, and the natural electrical currents induced in the wires were so powerful that operators received shocks. In some offices, the surges caused telegraph paper to be set ablaze. The system was so overwhelmed with natural electricity that some operators discovered they could disconnect their batteries and send messages using only the raw power from the storm itself. This event, now known as the Carrington event, was the most powerful geomagnetic storm in recorded history. It was the first time a solar storm had a direct, widespread, and destructive impact on human technology. It proved the sun could not only give life, but could also reach out and cripple our most advanced creations. The Victorian internet had been fried, a warning shot from the cosmos. But in a world still lit by gas lamps and powered by steam, the damage was limited. The world moved on. So, the real question is, what would happen if an event of that magnitude happened not in 1859, but today? To understand the modern threat, we have to understand what's happening on the sun. Our star is a chaotic ball of hot, electrically charged gas called plasma, with magnetic fields that twist, stretch, and snap. Sometimes, this magnetic tension builds and releases in an explosive event called a solar flare, a flash of radiation that travels at the speed of light. But the real danger often comes with what follows: a coronal mass ejection, or CME. Picture the sun launching a billion-ton cloud of magnetized plasma into space. That's a CME, a cosmic shotgun blast of charged particles, sometimes moving at millions of miles per hour. Most of the time, these CMEs miss us completely, flying harmlessly into space. Our planet is also protected by its own magnetic field, the magnetosphere. It's an invisible shield that deflects most of the solar wind and radiation that comes our way. When a CME hits this shield, those particles are funneled toward the poles, interacting with our atmosphere to create the beautiful auroras. A direct hit from a powerful, fast-moving CME, however, is a different story. It's a three-stage assault. First, the solar flare's radiation, X-rays and ultraviolet light, reaches Earth in about 8 minutes, disrupting the ionosphere, an upper layer of our atmosphere that our radio communications depend on. Next, an energetic particle storm arrives. These are protons and electrons, accelerated to near-light speed, that can damage the sensitive electronics of satellites in orbit. Finally, the main event, the CME cloud itself, slams into Earth's magnetosphere. This impact compresses our planet's magnetic field, generating massive electrical currents on the ground below. These are called geomagnetically induced currents, or GICs, and they're the primary threat to our modern way of life. They seek the path of least resistance, and in our world, that path is our vast, interconnected networks of metal wires. A Carrington-level storm today wouldn't just make the lights flicker. It could be an electronic apocalypse with potential costs in the trillions of dollars. Our civilization is now built on a fragile skeleton of technology that is incredibly vulnerable to these geomagnetically induced currents. Let's start with our eyes in the sky. Satellites. In February 2022, a relatively minor geomagnetic storm hit Earth. Just one day earlier, SpaceX had launched a new batch of 49 Starlink satellites. The storm heated Earth's upper atmosphere, causing it to expand. This seemingly small change increased the atmospheric drag on the low-orbiting satellites by up to 50%. Despite attempts to put them in a protective, safe mode, the drag was too much. Up to 40 of those brand-new satellites were lost, burning up as they fell back to Earth, a multi-million-dollar loss from a storm that was nowhere near Carrington level. An extreme storm could damage or disable hundreds, if not thousands, of satellites. This leads to the second victim, GPS. Solar storms disrupt the ionosphere, which can delay, distort, or block GPS signals. During the strong solar storm of May 2024, some farmers in the U.S. reported their high-precision GPS systems failing, leaving their tractors temporarily useless during planting season. In a major blackout scenario, GPS wouldn't just be inaccurate, it could be gone. This would ground most air travel, disrupt global shipping, and cripple emergency services. The biggest threat, however, is to the backbone of our world, the power grid. Long transmission lines act as giant antennas for those geomagnetically induced currents. The currents can flow into high-voltage transformers at substations, causing them to overheat and, in a worst-case scenario, melt down or suffer permanent damage. We don't have to imagine this. On March 13, 1989, a solar storm far weaker than the Carrington event struck Earth. The induced currents found their way into the Hydro-Quebec power grid. In less than 2 minutes, the entire system collapsed. 6 million people were plunged into a blackout for 9 hours in the cold of a Canadian winter. A Carrington-level event could trigger a cascading failure across entire continents. The largest transformers are custom-built and can take months or even years to replace. A mass failure could lead to blackouts lasting not for hours, but for weeks, months, or longer. And if the power grid goes down, the internet goes down with it. The data centers, servers, and switches that make up the cloud would all lose power. Even the submarine cables that carry over 95% of intercontinental data are at risk. While the fiber optic cables themselves are immune, the repeaters that amplify the signal every 50 to 80 kilometers are powered by long copper wires, which are highly vulnerable to GICs. A global, long-term blackout would mean no internet, no digital banking, no supply chain logistics, no credit card transactions. Our smartphones would be reduced to pocket-sized bricks. It would be a catastrophic failure of the systems that underpin modern life. The threat of a solar superstorm isn't some distant, abstract idea. It's a clear and present danger to the world we've built. Understanding this risk is the first step to preparing for it. If you're fascinated by the hidden vulnerabilities of our modern world and the cosmic forces that shape our lives, make sure to subscribe and turn on notifications. You won't want to miss what's coming next. If this all sounds like a remote possibility, consider this. In July 2012, a CME with the full force of the Carrington event erupted from the sun. It tore through Earth's orbit, right where our planet had been just 1 week earlier. We missed a direct hit by about 9 days. A NASA scientist stated that if it had hit, we would still be picking up the pieces. The recent solar maximum has given us more reminders. The storm in May 2024 was the strongest in 2 decades, producing brilliant auroras and causing temporary disruptions to GPS and power grids. It was yet another warning shot. The threat hasn't gone unnoticed. Agencies like NASA and NOAA are constantly monitoring the sun, trying to improve space weather forecasting to give us precious hours or days of warning. Engineers are working on hardening our power grids and building more resilient satellites. But our hyper-connected world remains profoundly vulnerable. The Carrington event was the moment the sun first showed its power over our technology. It changed communication forever by revealing a fundamental truth. The very star that powers our planet can also bring our civilization to its knees. We live our lives bathed in the light of a star, relying on a global network of technology that is, in the face of a cosmic storm, shockingly fragile. It reminds us that for all our progress, we're still subject to the immense and unpredictable forces of the universe. The question is not if another Carrington-level event will happen, but when, and if we'll be ready when the sky once again catches fire.